Hey everyone, it's Matt here with Night Run Studio, and in our last video we got scene transitions working so we can move back and forth between rooms in our game. We avoided the singleton trap that often happens for beginners by creating a bootstrap and used some additive scene loading to load and unload the scenes we're coming away from. That said, we left a few things dangling. So in this video we're going to clean things up by adding a nice smooth fade between scenes. We're going to make it so that our confiner lines up so the camera focuses where we want it to. And we'll also get our parallax manager working so that when we move from scene to scene, everything works nicely. All right, that's where we're headed in this video. Let's get started. All right, so let's get started by creating that nice fade to black between scenes. Let's drag our bootstrap up into the hierarchy here, and I'm just going to open up my camera and add a UI image onto this. We'll call this fade to black, and then I'll click on the canvas itself and just change it to a fade canvas. At this point, we can double click the fade to black to zoom out on it, then head over to our rect transform where we can make sure that we set the anchors to the corners and also expand in all directions. We can then go to color and just set it to a nice dark black. Next up, I'm going to go to the fade canvas itself and add a canvas group. This just gives our script an easier way to control all child elements to set their alpha, but also to decide whether or not they block raycasts or are interactable. With that done, we can create a new mono behavior script. I'll call this one scene fader, and we can go ahead and open that up. Let's begin by getting rid of our start and update method, and we'll just make a simple public canvas group reference, which we can call canvas group. Now, because we're going to be wanting to fade over time, we're going to need a coroutine here. So let's make a public IEnumerator called fade. We'll be able to use this for fade-ins and fade-outs, so we'll just pass in some information. The float will be the starting alpha. We'll also have a float for where we want it to be at the end, and finally a third float for the duration, how long we want this fade to take. Now, in order for it to like that, we're going to need to come up top and add the namespace system.collections. All right, so we'll begin here by making a new float called t, which will represent time, and we'll start it off at 0. Then we'll use a while statement. So while our time is less than the duration of the total fade, we want to go through this loop. First of all, we're going to take our time and we're just going to add time.delta time. So we'll consistently increment. And then we'll make our canvas group's alpha equal to, and here we'll use a math function called lerp, which is short for linear interpolation. And we just want to move from our starting alpha. So if it's a fade in, it'll be from a 1 to its endpoint 0. And here we'll just take our time and divide it by duration. That way we can figure out just how far into the total fade we want to be. We'll then yield return null, which will just pause till the end of frame. And then finally, just to account for any fractional little errors, we'll make sure that the canvas group's alpha gets set to the actual end float. Now we'll call that fade from our room transition manager. So let's head to the top here where we can make a serialized private reference to our screen fader. We can then come on down to our coroutine transition. And here, right at the beginning, we're going to fade from nothing to a total black. So we'll tell our scene fader to fade from 0 to 1, and we'll do this over a duration of about 0.5. You'll notice that I included yield return here, meaning it won't continue to execute the rest of the coroutine until that fade is complete. We can then come down to the bottom, and once again, we'll just wait until our screen fader has faded back from a full alpha to 0. Only this time I'm going to do it over about 1 second just to give it a little more time to fade in. Back in Unity, let's click on our fade canvas and add our screen fader script. And here it just needs a reference to the canvas group, so we can drag that right in there. We'll then go to our player, which is where we have the room transition manager, and make sure that our screen fader, or the fade canvas which is holding it, is dragged inside of there. With that done, we're ready to test. Now, because our alpha isn't currently on, we'll get a quick initial fade here. But otherwise, the fade's working, though you'll notice that we ran into a problem, which is just that the bootstrap loader has loaded twice. I'm just going to remove the bootstrap from the hierarchy here so that it can load itself properly. And there we go. That's looking much better, and we've got a nice, smooth fade in and out. That said, our camera's obviously showing things we don't want to show, so let's fix our confiner next. So let's begin by putting the bootstrap back into the hierarchy. And you'll notice here under camera that we currently have the confiner in our bootstrap. This doesn't make sense as each room is going to need to have its own shape of confiner, so let's move it up into room 1. We can then edit it so that it actually fits the boundaries of that room. Next, what we're going to want to do is just write a simple script so that whenever we enter a new room, the camera is able to find the confiner there. So let's create a camera manager. We can begin here by getting rid of our start and update method. and then add a serialized private reference to our Cinemachine camera. I'm just going to call mine vcam. We then need to make sure that we are using unity.cinemachine. Now that we can talk to our camera, we're going to need a private reference to the Cinemachine Confiner 2D. We'll just call this Confiner, and we'll find that in Awake. So as soon as the camera manager wakes up, it's going to look for the Confiner by going to our virtual camera and getting the Confiner 2D component off of it. Now then, our manager can talk to both the camera as well as to the component that's going to be confining our camera. So now we just need to actually make a method that will allow it to set which collider is going to be its confiner. So we'll call this set confiner, and it's just going to take in a collider 2D for whatever the new confiner is for that scene. Inside of here, we'll just tell the confiner component that its new bounding shape 2D is equal to that new confiner. Back in Unity then, we can click on our camera and make sure to add the camera manager and drag our Cinemachine camera into the vcam slot. So the question now just becomes, how will our camera manager actually get the information of which collider it's supposed to use? And for this, we're just going to write another simple script. So we'll create a new mono behavior script, and we'll just call this one camera confiner provider. This is going to be an incredibly simple script, as it's just going to have a public collider 2D reference called confiner. That's it. Back in Unity then, we can put this script on our confiner, make sure to drag in the actual collider that it's using, and then we'll be able to hook it all up in our room transition manager. So now we'll just make the confiner finding part of our transition coroutine. So let's begin by making a serialized private reference to the camera manager. Then head on down to our transition coroutine, and right here, right after we've set up our room, deciding where the player should spawn to, we'll set up our camera confiner. Next, we'll come down below our setup room method and create a new private void setup camera confiner method. So whenever we come into a new scene, we'll first of all find our camera confiner provider. We'll call this one provider and make it equal to. Now here, at least temporarily, we're going to use find first object by type and just search through the scene for a camera confiner provider. Once we found the provider, we can just tell our camera manager that it should set its confiner, and here we'll just talk to the provider and pass along the confiner that it has stored inside. Back in Unity now, we can click on our player, and there's now a camera manager slot here, so we can just drag the camera right inside of there. We'll then remove the bootstrap, and if we tried to test this right now, we'd run into a little problem because we haven't set up room 2 with a confiner yet. So let's drag it up into our hierarchy, copy the confiner from scene 1, and then just for this one, we just need to make sure that we edit its collider shape so that it matches the new room that we're headed to. I'm just going to do a quick check here to make sure that my doors line up nicely with where the camera's going to cut off, and then with that I'll remove scene 2 and give this a try. You'll notice when we get into scene 1, it's working nicely with the camera snapping in position. We've got a little bit of a rough cut there, which we'll fix in a moment, but otherwise the confiner is in fact finding itself each time. Now that little bit of jumpiness that we experienced there comes from in our transition. All it is that we're starting our fade back in before the camera's found its position. So let's just come before that line where we'll do a yield return new wait for seconds. I'm just gonna go with 1/4 of a second here, as that should be enough time for the camera to get in place. All right, and with that little change, things are working much nicer. You might notice that there's just maybe the tiniest little bit of where I'm off still, in which case you could expand that to 0.3 seconds, but that's good enough for me. All right, now the last thing I want to clean up in this video is our parallax. If we drag our bootstrap into the hierarchy and click on the camera, you can see that our parallax manager is currently disabled, but unfortunately, it needs to have the elements that belong to each individual scene, so it's just not going to work here. So I'm just going to copy this one, then remove it. Then we'll head into scene 1, and I'm actually going to paste it onto my confiner here. I'm going to rename this, as it's actually going to be holding a whole bunch of different camera components that we need. All right, and then in the hierarchy, I'll just expand my world so that we can see all of the different layers we've created. I'll then open up the parallax manager and just drag these in one by one. At this point, the big problem we're going to notice is that our cam transform doesn't work because the camera's actually in a different scene. So we are going to have to clean this up. So first of all, we're going to need a way for our scene scripts to get a hold of our camera, which is in our bootstrap. So let's head to the camera manager and just make a public transform reference here to our camera. Now we'll head to our parallax manager, and we're going to change start here to a public void initialize. This will just make it so that when the game starts, it doesn't give us errors because it doesn't know where the camera's transform is. So now it'll take in a transform for the camera. We can then make sure that we store that camera transform right away. And now we'll be able to set the position for our parallaxing without any errors. Our final step then is to bridge the gap between our scene and Bootstrap stuff, and we're going to do this again through our room transition manager. So after we've set up the room and set up our camera confiners, we can now reset our parallax. I'll just close up these other methods for readability here, and now we'll make a private void reset parallax method. Here, we need to first of all find our parallax manager. And so whenever this gets called, we'll just search the scene we're currently in until we find the first object by type of parallax manager. Again, we'll make this more efficient in the final video. Now just to avoid error messages, we'll make sure that our parallax is not null, meaning we actually found one. And if we have, we'll tell parallax to initialize itself, and we'll just pass along the camera manager's chem transform reference. Back in Unity, we'll just want to go to our Bootstrap, click on our camera, and make sure that our camera manager actually knows where the camera is. We'll also want to make sure that our parallax is set up for our second room. So let's go to room 1, copy the parallax manager component, and then just head to room 2, where once again we'll go to the confiner object, paste the component as new, make sure to rename this as camera components, and then set up our layers for the parallax once more. Finally, we can remove the Bootstrap and room 2 and run our test. Now the game fades in nicely, our parallax is working great. When we run to the next scene, we get a nice smooth fade, the camera's in place, parallax is working, and we can go back to the first room no problem. Alright, that's looking pretty darn good. That said, we're getting just one little tiny error that happens right when the game begins. Now this error won't actually affect gameplay, but we don't want error messages popping up. So let's head into our parallax manager. And here in late update, just want to make sure that if there is no cam transform, we return, meaning we don't actually try to run the parallax until the transform for the camera's been set up. With that done, we can now run a full test. Parallax is working, the camera's working, fades look great, and we can head back to the other scene no problem. All right, in our next video, we'll just set up a service locator so that we can make our finding even more efficient. And we'll also be using that a lot as this series progresses in order to make sure that we can find components we need as we move between scenes. Hope to see you in that video. Until then, this is Matt with Nightrun Studio. Cheers.